So we'll go through example 15, page 434. Okay. Now, just about lines that intersect. When you've done it in 2 dimensions before, what have you been doing? How have you solved the intersection of 2 lines? Do you want to work with me rather than in spite of me at the moment? Or how have we found the intersection of 2 lines? With a calculator, okay, but if we don't have a calculator, how have you done it as well?
Oh, it's the old thing.
Just 2 lines in 2 dimensions, straight lines. Whatever. How would you find the intersection of 2 straight lines? Simultaneous equations. Okay. Simultaneous equations. How many simultaneous equations do you need to find the intersection of 2 straight lines in 2 dimensions? 2, because there are 2 unknowns. Right? The unknowns would be what? Not x, actually. Not the x and the y, actually. No.
No.
We're not talking vectors now, so. Well, we have to find x and y. Actually, it is x. How do we do it? We have to make sure we've got the 2 equations in mx plus c. So you have to know your mx, the m, and you have to know your c for both equations to then be able to find the x and the y that are shared between those 2 equations. If you're given the, well, in IB it's actually ax plus b, isn't it? So if you're given the 2, that's fine. Alright. There are only 2 situations with 2 dimensions, which is the lines cross, or they are just talk properly, I can't hear. Parallel, thank you, no, yes. They either cross or they're parallel. There's only 2 situations. 2 dimensions, 2 equations, 2 possible situations. 3 dimensions, so vector equation of a line in 3 dimensions. How many equations do you think you're going to need? 3, essentially. Sort it out. What are the 3 options, do you think? So lines will either intersect each other, they will either be parallel. Is there a 3rd option?
Yes.
Can they not touch and not be parallel?
Yeah.
How? Give me a reason. They'd be skew. And what does skew mean?
The lines are not parallel and the values are not consistent.
And if you had to visualize that, what would it look like? Like Zorro.
Yeah, perfect.
Got the sword gun. How can you imagine 2 lines if they're not parallel? They still don't cross. How does that work in 3 dimensions? Can you visualize the situation?
No, well, when they're not parallel.
They're not parallel. Therefore,
Well,
you could not run a train on them.
They're different depth in the incident.
Okay. There's a different depth, but maybe they're not parallel, but they are going maybe, so if I have, I obviously can't draw in 3 dimensions, but here are my 2 lines. If I'm working in 2 dimensions, they're either parallel or they cross. But they could be parallel, they cross, but if I do that now, in 3 dimensions, suddenly they're not parallel and they don't meet. Right? What if I do it like that as well? Will they ever cross? So that's a simple case, just changing the depth, but they can also be an awful lot of situations where they wouldn't ever meet. So you have to be aware that when you are solving these problems, sometimes they're not going to cross. And they're not necessarily parallel. So you've got those 3 situations, it says in the book. They can intersect, they can be parallel, or they can be skew. I would suggest that you need to make sure you make a note and understand those terms, just in case you are asked, describe the relationship between 2 lines. these two lines, how you would find those out. Right? I'll leave that down to you to write, so don't write it down now. Let's go through how we go about finding the intersection of R1, which is given as 3, 0, minus 1, and plus S, 1, 1, 1, and then we've got another line R2, which is 6, 2, 0, plus T, 0, 4, 8. Okay, so we're looking for the show that the lines do intersect and find the coordinates of the point. So, typical exam style question that we're going through. Right. Now, what we have to do is we're setting up that there is a coordinate. So we've got equation of two lines, but we're setting up there is a coordinate that where they meet, if it's true. Okay. So that is why you'll notice in the example we are looking for the x, y, z coordinates. Okay, x, y, z. For each one of these, we're looking for that coordinate that's the same for both. So now R1 will have a coordinate, R2 will have a coordinate which is given by that equation. So that's what we're stating now. Okay. And we're stating that, you know, to find, how do you find the x coordinate using that equation? So the x coordinate is given by, in this equation, 3 plus s. Okay? The y coordinate will be s. The z coordinate will be minus 1 plus s. Okay? Happy with that so far? So that is a coordinate in terms of s, which is the first line. You understand why there is an s and a t? So that was a no. What did we have before the vector of equation of a line? If you look back, what have we used before? Just had t, haven't we? Why have we got an s and a t in this case? It's as simple as all the other times you've used algebra when you're comparing things. You use an s and a t because they're different lines. So I don't want to put t and t because then I'd be using the same thing for both lines. What is, by the way, do you remember what the s or the t represents in terms of the vector equation of the line? So just check your understanding. The what? Okay, so yeah, this bit deals with the magnitude and direction. So s and t deal with the magnitude. Right? So we have s and t because they might be different. Okay. Well, let's set up our x, y, and z for this line as well. What are they? X is 6, y is 2 plus 4t, z is 8t. Okay. So, we've got those. We've given the coordinates in terms of s and in terms of t to do with the two different equations. We're trying to find out where they cross. So where they cross is when what occurs.
The point where would they share?
So R1 would equal R2. So we can set up another set of equations using these and state what? That 3 plus s equals 6. So we've got this x with this x. We've then got s equals 2 plus 4t. And we've got minus 1 plus s equals 8t. Now we kind of have to do it whichever one comes first. So is there anything in that set of equations that we've just written that we can deal with already?
Yeah, the first one.
The first one, and what does that give us then?
S equals 3.
So S equals 3. Okay. Now that helps us with the rest, doesn't it? So this would be, that's number 1, just makes room for myself. Number 2, we've got now 3 equals 2 plus 40. Or, number 3 gives me minus 1 plus 3 equals 8t. Either one can be used now to find t. So have you figured out what t is? Quarter. Let's work in fractions. Alright. So I've worked out what S is, I've worked out what T is. Okay. So now I need to figure out, well, what's the coordinate that where they match? So we reckon X, Y, Z will be what? What would it be? Well, we should match. So this is the thing. If we go through that process and now we've got everything works, then we know we've got an intersection. If after finding S and T it doesn't work for both sets of equations, we know we've got an issue. It doesn't work. Okay. So what we've got to check is the X coordinate should be 6. Because I got that coordinate from this line. Easy. Right, it's the starting point. But does that also work in R1? So 3 plus 3 makes 6. So that one's fine. We're okay with that. What about the second Y coordinate we think should be 3, because it's just Y equals S up here. But do we have that here, there as well? So 2 plus 4t, if t is a quarter, should give me 3, yeah? Yeah, so we're all right there. And 8t will give us 2 minus 1 plus 3 makes 2. So we're all right. So we think that the coordinate where the two match is 6, 3, 2, and it works for both. So that's where those two lines intersect. So there would be a problem. So if you went through this process, right? Remember in the question it says show that the lines do intersect. Okay. So if you're looking at the page, it says since the value of S and the value of T are consistent for all 3 equations, the 2 lines must intersect. Okay. So, for instance, at this point here, when you're working out S and T, if something doesn't work, so S being 3 doesn't work in one of the other equations, then you know the lines are not going to intersect. Right? So that's how we get that show that the 2 lines intersect or show that they don't. So if at this stage here, when we're trying to figure out what T and what SI, if that does not give you consistent values, then they won't intersect. Does that make sense? Right, so you've now got, what, 15 minutes to have a look at exercise 12K. and I'd suggest you get through them as quickly as you can while I'm around. You can ask or not, it's up to you. Because after break we'll have a look at applications of vectors, and then that'll be done, and then we can get on with the next topic. Alright, I'll let you go on.